Hello everyone, welcome back. Hope you are doing good and you have enjoyed previous lecture where we discussed basic elements about computer programming languages. The idea of this lecture series is to provide some insight or about computer programming fundamentals, so that you can apply those basic fundamentals and can write better programs. Um, From this lecture onwards, I'm going to be discussing about C++. C++ is my favorite programming language. There are many reasons why I still stuck and love this language. You're going to learn slowly. This is the first, I think, first lecture for C++ programming, and we're going to discussing today basic elements, and from now onwards we would be discussing more in terms of C++. So have fun. Let's say C++. In nutshell, what is C++? I did put a picture of an elephant here. That is more like, I would like to say that C++ is like this elephant. It's enormous, giant. It offers many advantages, many flexibilities, yet structured, very robust, closer to machine, and highly performance. It gives high performance in terms of how you write your code executes, or let me put it in other words, what you write in C++, the code in the end gets translated to as close as machine language, which gives enormous advantage as compared to many other languages, say for example Java or Simula, or I shouldn't say Simula, Java is in that case, it's like more for GUI sort of thing. You might have heard this story about the elephant and the blind man. In the same way, like like many programmers or many students out there, at some or the other point, they think in that way. Oh, I know C++. Not. It's enormous giant. It's the similar analogy here. But let's try to simplify things. In simple terms, what C++ offers? What is C++? It offers type safety, which is important. We don't want to mess around with our types of our objects or named elements in our program. Resource safety, this is very important again. For example, think about your car fuel tank or your car internal system is not efficient enough and your car is leaking gas. What's going to happen? You are wasting useful resource, which is gas or petrol or diesel, whatever it is. So if the engine is not controlling it properly, it's wasting. So for applications which are written for engine control, it becomes very important that my code or my program gives me good performance, it is predictable, and blah blah blah. So in terms of computer programming and computer science, memory is a precious resource. If the language doesn't offer me good mechanism for memory management, it's just not gonna be efficient. My program gonna be leaking memory. So the C++ here, it's very good. It enforces actually for the memory organization. The compiler wants you declare the object, you allocated the memory, but you forgot to destroy it. It's more elegant way of handling the dynamic memory. Performance, of course, it's very close to machine language, to machine, or in other words, C++ is much more closer to machine than Java or any other language. People say C is much more closer to C++, but now with the recent version of C++, the gap is very, very tiny. But the advantage what C++ offer compared to C is enormous. High performance I need. For example, you are talking on your phone and your computer software which is in your phone says, oh, I have to hang up your call, I just run out of resources. That's too bad. It's leaking memory somewhere. Predictability. That is very important, that my program I should know that my program is able to execute in a specified time. I should have some idea, or I should have sort of, that my program is going to give me output within time. Predictability behavior becomes very important. Say for example, software which is written for aeroplane or a jet. You don't want any unpredictable behavior. Think about it. So in nutshell, 4 very important elements which C++ offers. We can say C++ is a lightweight abstraction programming language. It offers it offers abstractions, data abstractions in a beautiful and elegant manner. One can do. The strengths of this language is in terms of software infrastructure, resource constrained applications, for example, real-time applications, embedded systems, softwares for embedded systems and all. By the way, I'm taking the notes for the C++ from the book written by creator of C++, Estrop. I'm sorry if I'm not pronouncing his name and he's watching this lecture. Please excuse me. He's a great guy. Very beautiful language he created, and his lectures are awesome, beautiful. Let's talk about programming styles. C++ supports direct 4 programming styles. First, procedural programming style. It's coming as an inherited from C or similar programming style languages, procedural programming languages, or in other words, it's backward compatible to C. But here I would like to mention that one doesn't need to know C in order to program in C++. One can just directly go and write a beautiful program in C++. C is a subset of C++, in other words. Second, data abstraction. You can basically do a beautiful job of abstracting data at different levels. You can do abstract classes, you can do concrete classes, and so on. You have much more flexibility to organize your data, to organize your thoughts. Object-oriented programming. Those who are not familiar with object-oriented concepts, don't worry, take it easy. You're going to learn slowly. But the object-oriented C++ supports object-oriented theory. You can organize your concepts in terms of classes, and then you can evolve the instance of that class into the object. For example, human is a big class. Its object can be a man and woman. Both are, and man and woman can be a class. They both are inheriting properties from the humans, their parent class, and so on. The basic idea here is that design and implementation and use of class hierarchies. And fourth one is generic programming. What do we mean by generic programming? It's like, for example, if I'm writing a move function for a car, then if I change the parameter from the car type to, let's say, a object, or let's say aeroplane, So the same move functions should be applied there. C++ offer a beautiful way of doing that via templates. Now let's talk about programming in C++. That's a very big question. How you can write a good C++ program? That's a very difficult question, but answer is very simple. It is hidden in simplicity. The more simple one thinks, the better they tend to program. Always remember first KISS or the KISS, K-I-S-S, keep it simple, stupid. Well, it's just a kind of slang saying, but yeah, that is very elegantly applies here. KISS, keep it simple. The more simple you think, the more are chances that you can write better programs. One can mess around with C++ program. They can write ugly programs which can hang, which can hard to debug, because it's the language offers freedom, but it's same way like the human beings are free, but they can create things or they can destroy things. Same way you can do beautiful things in C++ and you can do ugly things too. Depends what you choose. So always remember simplicity. Let's try to put some words on simplicity. Represent your thoughts, ideas directly into codes. For example, always remember divide and rule principle. You have a big problem, you have split in, you got to think about splitting that big problem into smaller pieces, and those smaller pieces in terms of functions, where each function is doing a small job and returning output of some kind or some type. Second one, represent relationship among those ideas directly into the codes. What does it mean? That relationship between two different kind of objects. So you can write a function. Okay, for example, you and your friend, you want to give this book to your friend, so you can write a function, give book to him, and you want to receive some money from your friend, so you can write a function, receive money from my friend. Isn't it simple? So you can implement those relationships. Think about in terms of objects, how they are related with each other. We're going to learn slowly. It will come more clear to you. But the basic idea here is that simplicity, arranging ideas into codes, and writing functions basically implement those interfaces, or give and take via functions. And what values do you hold? Say you hold this book, you hold this pen, you hold this much money. Those you can you have your data, you have your private things. In the same way, the C++ class offers you the private and public members. So often you don't want to put the data items which you want to hold in memory to public. So data items are what you hold, those variables are private. The functions which you interact with other objects are public. Keep things simple. Keep information local. Avoid use of global variables. This is very important, that you break the big problem into small pieces and then you use local variables. Do not use global variables until or unless it is necessary. Avoid using it, because it has to, then you will keep forget and it leads to more bugs in your code. It's not a good practice. Do not over abstract. This is very important. If you don't find a reason why you should to abstraction. Don't do it until or unless something is necessary. Think about laziness. If you don't have to go out, don't go out. But that's something else. Think for example, students. They don't. Most of these students, they don't study until or unless they are required to do that. So keep that in mind. Do not over abstract. Now let's say a simple program. Int main. Main is the main function. Int main. This is a minimal C++ program you can write. Let's go a little beyond and write a first hello world program. As you can see in this, we are include IOStream. So we are taking that, including that library in our program. So whatever names are defined in that, those gonna be visible. Now this line, int main, this is our main program line, std : cout. Std means that the standard namespace, which is defined in IOStream library, and there is a name cout. So that is also defined. What does this type or this object cout does? This is a backward arrows. This two arrows, this operator tells me that what is on my right side, put it onto my left side. So on my right side, we have hello world and \n. This is a new line character, funny thing, but it's like it will put your cursor onto the next line. So whatever is here, put down onto the left side. Left side is nothing but it is telling me go to the standard output, this cout. So your output is going to print on a screen. Now let's go and let's talk a little more complex program. Include IOStream as we did earlier. This line is interesting here, using namespace std. If we define this line, it means that we do not have to write std : again and again. It makes all the names visible from std without using std : std stands for standard. This function, we define this function. Double is the type of function. Square is the function name, and this function is going to take one variable whose type is double. This is how the function is going to work. Return is the return value for this function, and x multiplied by x is the expression here. I think I misplaced this semicolon. So this semicolon should be before the bracket. See, that's how it happens when you type, but this kind of errors you can catch when you do compile. This function void print square. So now you got the square, but this is square where to print. So this print function will print wherever you want to print. So for now I'm printing on a screen. So I define this function print square, and its type is void, means it will not return any value. Input, it takes the input argument of type double, and we define a name x, that is x is variable. And same thing, we just print on the output screen. Now how we can call, so we had a problem that get the square of this variable. We chop this problem into two functions. One is to calculate the square, second one to print. Now how we call this function in our main function? We define like that, main and print square, and in the brackets whatever value we want to put it here, and when we execute this, we'll get the result which is the square of this value. Essentially all executable code is placed in functions. This is important. because ideally you would be the ideal way, to create more functions, and directly or indirectly you would be calling those functions from the main program. Let's talk about types and variables. Every name, every expression has a type that determines the operations that may be performed on that type. For example, int is an integer type, inch is the name. What it means, what this line means, that inch is a named object of type integer. So all the operations which can be performed on integer can be performed on the value which this inch name will hold. Fundamental types: bool, char, int, double. Bool stands for boolean, char stands for character, int stands for integer, double precision floating point. Now this figure shows me, or these boxes tells me how much memory each type will have or will allocate for itself from the memory storage or memory area. Bool, 1 unit. Now 1 unit can be different for different machine architectures. Say for example 32-bit processor, 64-bit processor, 8-bit processor, and so on, or according to what machine defines. So for bool, for simplicity here, 1 unit, character type 1 unit, integer type 4 units, double precision type 8 units. Don't worry about this integer, I think I forgot to take it off. A type defines a set of possible values and a set of possible operations for objects. So for example, this inch is a variable, or its type is integer type. An object is some memory that holds the value of some type. Inch is a named object. This is nothing but some memory that holds the value of certain type or some type. So the memory, let's say in 1, 2, 3, 4, 4 units memory is allocated to named object inch of type integer. What is the value? A value is nothing but a set of bits interpreted according to its type. A variable is nothing but a named object. So inch is a variable, nothing but a named object. Now let's talk about pointers and arrays. Don't get afraid with the pointers. Pointers are very simple. Pointers are nothing but telling you the address. It's like a postman knows the address of your home and delivers you the mail. He doesn't have to take your home to the post office and then put the mail in your home. No, he just knows the address of your home. He goes to your address, delivers the mail. Same way pointers. Pointers, they just hold the address of certain memory where your actual data is stored. Think about in terms of address of a warehouse. As simple as that. Char, this line defines v6, means, so before going to this line, let me talk about arrays. So I did a lecture on array when I was doing the second lecture in algorithms lecture series. I was discussing about arrays. If you haven't watched that lecture, I would recommend you to watch it to get some basic familiarity about arrays. Now here in C++, this line char v6, what it says that it defines an array of 6 characters. Good. Now v6 means the 6 elements or 6 memory units, 6 memory units. Each unit is holding or type 1 character, as in this figure, and we are indexing from 0. So 0, 1, 2, 3, 4, 5, 6, 6 units. char asterisk p, what does it mean here is that the named object or the variable p has a type or holds a value which is the address of a character, or in other words pointer to a character. Now this is uninitialized, so it's a dangling pointer, not good. We don't know what this pointer is doing. Of course C++ has good capability for garbage collection and all. It can warn you that this is dangling pointer, but the good way is to assign the address to this pointer. So let's talk about initialization. So we initialize here. So if we put ampersand in front of v, what it means that we're gonna take the reference, or in other words the address of the third element from this v array. Fourth element, because we're going to index from 0. So 0, 1, 2, 3. So 1, 2, 3, 4, fourth element. So now this line tells me that now p points to array v's fourth element. P points to fourth element, that is v3. Its address is stored in p. Now char x equal to pointer p asterisk p. So when you write asterisk, or when you prefix the variable with the asterisk, it means that it's going to get the value which is stored at the p address and put it into variable x. So p asterisk p is the object that p points to, or the value which is stored, in this location where this p is pointing. Okay. Now t is some type. If you prefix, okay, now t ampersand, when you write ampersand suffixed any type, it means that with respect to reference. So it is similar to pointer, however this cannot be null. So it will always have, the reference or the address where it is pointing to. T asterisk r is pointer to t. In other words, t ampersand r is reference to t. Prefix unary asterisk. So if you prefix asterisk means contents of, in other words, just too easy to remember. When you prefix ampersand means the address of, and when you suffix ampersand means reference to. So pointers and references are similar, except references are so pointers is a legacy from the C, but the references are more elegant and better approach for handling the memory addresses. The reference can never be null. It will always hold the address. User-defined types. C++ offers user-defined types. You can define your own types. For example, structures, classes. Say for example, you have a container, and in that container you want to put cookies and you want to put chocolates. You want to put different items, but you want to call it a type. Let's say mixed chocolate box. Good, you can write it a structure. For example, here a structure vector which holds variable of integer type and a pointer which points to a double type memory, or which points to a memory address, and the memory holds the value which is of double precision type. Okay. This is, you can define the structure, and when you want to use, you just simply write a type vector and then write the object, named object. So this is an old way in C. This is valid in C++ too, but in C++ we use more elegant approach of using classes, which offers more flexibility and added advantages. Cleaner approach, better memory, better handling. In C++, you can write the same thing as of vector. You can specify public. Public type means anybody can access. Those are functions basically. So when you write a function with the same name as the class, it is declaring a constructor. Constructor is nothing but when an object of this class type of the vector type will be called, this function will automatically be executed, will create the objects or elements, will create or will hold the memory, or in other words, my tongue is slipping here, but the idea here is to construct the object. How is going to construct is written in the constructor function. Okay, element is a function, new is a keyword, it allocates the memory. How much memory is going to allocate? It's going to allocate, and what kind of memory? Okay, double precision type. And how much spaces? That defines in the variable s, and that takes the, so this function takes the size. What is the size of s, or the another array size, and it will run in a loop and will give you the elements of this class vector. Now this is the destructor. Destructor function is same thing. You write this tilde sign and vector. You write this function with the same name as the class name, and then define the how it's going to destroy. So you write the delete all the elements, ELEM, all the all the dynamic memory, for example here. So it will delete whatever memory you have taken from the free memory pool and will destroy it. So this will ensure that you will not have any memory leaks. These are some other general purpose functions here. You're doing operator overloading, and so we're going to learn all these slowly. And in the private, you just hold your data, private data members, like the actual store, or the functions, or let me put it in other words, the functions are the procedures, interacting with the outer world. Those goes to the public. And the private, those belongs to me within the class itself. These are basically the containers which hold the data. So what I have here is the element which is pointing to an object of type double. And then I have another variable named a variable of type integer, which says me what is the size of this element array. Isn't it interesting? We converted the structures to C++, classes. It looks more elegant. You can, for example, in a structure world, everything is open. Anybody can access a private or public data member. There is no such concept. But in C++, the class is a more elegant way. It's a superset of a structure where in public you let everyone or the outside world to access the public members, and in private you just keep things to yourself which you don't want to share with others or the outer world. I guess this ends to this lecture. If you haven't subscribed to my channel, do not forget to subscribe LeProfessor YouTube channel. If you need private tuitions or if you need any help with any of the subject I have mentioned on my website, leprofessor.org, you may feel free to contact. I would love to help you out in your courses. And as I always say, algorithms are everywhere, or say here I should say programming. C++ is everywhere. That's okay. That comes to an end for this small lecture. Hope you have a wonderful day, and don't forget to subscribe to LeProf's channel for more exciting videos. Thank you everyone. Have a wonderful day.